तो सबसे पहले क्वेश्चन में आने से पहले फर्स्ट आई वांट टू अंडरस्टैंड व्हाट इज कुबरनेटिस.
Recording in progress.
So what is Kubernetes? We also call it is KATS. So sometimes in interview, the interviewer or who is scheduling your interview, he may ask, uh, what is the experience of K8? Okay, so don't get confused. It means they are asking about the Kubernetes. So Kubernetes, if you why we are calling as a K8? If you calculate this word Kubernetes, so you can see it will start from the K and the last letter will be S. So K and S, if you count between K and S, you just see I am counting from the right side. E 1, 2, 3, 4, 5, 6, 7, 8. So there is a 8 letter between K and S. That's why we are calling as a K8S. Okay. So this is abbreviation is called as a K8. So here technically, if we see the definition Kubernetes, it's like open source container orchestration platform. Okay, we can call. So here, this means it's a free developers and it is free for the developers and the company across the world together. Okay, and it will maintain, and this is like the project was originally developed by the Google. So it is actually the Kubernetes. It is developed by the Google. Okay. So we can call as a container orchestration tool. So this means container orchestration means like it's managing the multiple container automatically. That is why we are calling as a container orchestration. So Kubernetes automatically deploy, or we can say starts or stops, or we can scale up, and we can monitor the containers. Okay, so in Kubernetes basically we are managing the multiple containers. We can deploy, we can start, stop, scale, and monitor the containers. Okay, so here this platform, this provides the complete environment where the developer can deploy and manage their containerized application. Okay. So in simple word, if you ask, so Kubernetes, it's like a very smart system which automatically deploy, or you can say scale and manage the containers. Okay. So this is Kubernetes actually. So if you ask what is like container orchestration, so container orchestration means like it will automatically coordinate and manage the multiple containers. That's why we call it a container orchestration. When application run in container, because we know the application is running inside the container, okay, and we have the node, we have pod. So in the node we have multiple pods, and in the pods we have container where our actual application it is running. Okay, so when the application run in container, there are many operational tasks like it is we can say like deploy containers and scaling the containers, restarting failed containers, and also we are monitoring application health, managing the networking between the containers, or also we are handling the application update or rollbacks kind of things. If all this work is done manually, the system like becomes a very complex, right? Suppose you are working in the very uh, enterprise level project, okay, and there are thousands containers they are maintaining. So it is very difficult to manage manually all those containers. So we required some tools to manage these thousands of hundreds of container. Okay, so this is the tool which provides uh, thousands of your container. They will manage and automatically, no need to do manually tasks, no need to go one by one container. Okay, so all the containers it will manage by the Kubernetes. Okay, so that is why Kubernetes manage all these tasks automatically, so that application can run in a like reliable or efficient way. Okay, so why Kubernetes is important in DevOps? Okay, just I am giving you the foundation. Then we have to go with the particular question wise. Okay, so why Kubernetes is important in DevOps? So in modern DevOps, Kubernetes play a very important role. So that means the goal of the DevOps is, what is the goal of DevOps? We have like continuous integration, CI we can call. We have continuous deployment, CD. We have also we have delivering the software in very fast, right? Uh, yeah. So in Kubernetes, it will help to achieving these all goals. It helps to organization to run the application at a very large scale, to reduce the manual operational work, to improve the system reliability, to maintain the high availability, and also to we have automate the infrastructure management. So because of this, the Kubernetes has become a standard tool in the cloud native architecture and in the market and in the DevOps ecosystem. Okay, so that is why Kubernetes it's one of the very popular tool in the, you can say, in the world. Okay, hope you understand what is the Kubernetes, why we are using the Kubernetes. Okay, we can move now. Uh, so if you talk about why, uh, why do we need Kubernetes when we have already have the Docker? Okay, once we have already Docker, then why? What is the need of the Kubernetes? This is the question. This is very valid questions. Okay, so before, you need to understand, sometimes uh, someone has asked me, ki, we have already Docker, then why we need the Kubernetes? Okay, so yes, it is very valid questions. We have already Docker, then why we need the Kubernetes? Because before Kubernetes become popular, developers mainly use Docker to containerize the application. Containerize the application. Only people are using the Docker. Okay. With the help of Docker, so what we are doing? So we can create the container image. We can run the containers. We can package the application along with their its dependency. We can say for the for like a small application. Okay, Docker is enough for the small kind of application. Okay, but when application run at large scale and hundred or thousand of containers are involved, the problem will start. Docker will fail there. Okay, Docker will not manage all those thousand of containers. For example, if an application has 100 containers, so managing them manually becomes very difficult. So you have to, like, manually, what you have to do? You have to start the container, you have to stop the container, you have to restart the failed containers, you have to scale the container when the traffic increases. Okay, these all things are we are doing manually. You can monitor the container health. So these all, like, you have to ensure the application availability. Okay, so doing all this manually becomes like time consuming, you can say, and error prone also. Okay, so to solve this problem, so Kubernetes was introduced in the market. Okay, so the Kubernetes problem solves, like, Kubernetes eliminate the difficulty of managing the container manually. Okay, Kubernetes automatically deploy the containers. It will scale the application based on the demand. Okay, and also it will restart or whatever the when the your containers failed, okay, so Kubernetes automatically it will start those container which is failed, okay, and it will also managing the load distribution, maintaining the desired state of the application. So whether you have 10 containers or 1,000 container or 5,000 containers, Kubernetes can manage everything efficiently. Okay, so now the concept is clear. If we have the Docker, then why we need of the Kubernetes? Okay, so that is the reason we are using the Kubernetes. Okay, so if you talk about the core purpose of the Kubernetes, the main purpose of the Kubernetes is to provide the container automation at large scale. This means like developer and DevOps engineer do not like need to worry like about the infrastructure management. They can focus on developing and improve the application. And Kubernetes automatically runs and manage those containers. Okay, so this is why we are using the Kubernetes, and this is the reason the Kubernetes is popular in the world. Okay. Then what is Docker and what is Kubernetes? Okay, in simple term, what is Docker? So in simple term, Docker is the tool for packaging and running application inside the container. Okay, Docker is a tool for packaging and running the application inside the container, while Kubernetes is a tool for managing those containers and coordinating their deployment and scaling across the multiple machines. Okay, so Docker is one of the like most popular containerization platform, and the Kubernetes, it is for container orchestration in modern cloud native architecture. Okay, so that is the main difference between the Docker and the Kubernetes. Okay. So here that is the now we are coming in the questions. What is Kubernetes? Why we are using the Kubernetes? Okay. And we have already Docker. Then why we are using the Kubernetes? Okay. Hope you understand now. Now we can talk about the architectures. In the most of the interview, almost everyone, they are interviewer are asking the architecture about the Kubernetes architecture. Okay, so this is very important questions. Can you explain the Kubernetes architecture in the interview? Interviewer can ask. Okay, can you explain the Kubernetes? What are the what are the main component of the Kubernetes? Like the controller, and we have worker node, okay, master node. So how they are communicating inside. So basically they will ask about uh, the architecture of the Kubernetes. Okay. So to understand the architecture, first we need to understand the concept of the cluster. Okay. Say Kubernetes cluster generally consists of, we can say, minimum one master node. It is not like only one master node. It may be multiple master node we have in the cluster. Okay. It's totally depends on the size of the cluster. Okay, so at least minimum one master node and multiple worker nodes we require. The master node, the job of the master node is to control and manage the clusters, and the worker node job is to run the application and the container. So basically, the main our application, it is running inside our worker node. So if you can see the diagram here, you can see this is the master node, and here this is worker node. So we have chosen two worker node, one worker node here, another worker node is here, and you may choose one more worker node based on your architecture, or it totally depends on the your application. Okay, so here I have shown like two worker nodes and one master nodes. If you can see here in the master node, you can see the component of the master node. We have API server, we have etcd, we have controller, we have scheduler. So this 1, 2, 3, 4, this is the four component, main component of the master node, or we can call as a controller manager. Okay, there are four. I mean, yeah. So this is uh, the component of the master node, and this is the worker node. And here, the component of the worker node here, we have kubelet, we have container runtime, we have network proxy. Okay, so these are the main component of the worker node: kubelet, kubeproxy, container runtime. Okay, here. So and here we have this is the node, and inside node these are the component, and we have multiple pods so inside the worker node. Okay, so each worker node or each component, it has own their functions and their responsibility. Okay, so the master node also we can call as a controller plane, control plane, control plane. So also you can talk about, we have the control plane and we have worker node. Okay, in the control plane, so we have different component like API server, controller, scheduler, etcd, and we have worker node. Okay, so now we can understand the role of master node and we can call as a control plane. Okay, so here control plane, the master node, it's we can call as a, like a brain of the Kubernetes cluster. It controls and manages the entire cluster. Okay, you can understand it. It's like a manager who supervises employees and ensuring everything is like working properly. Okay, so you, as for the understanding, you just uh, in the interview, these kind of terms you have to use. Key master node, it's like the brain of the Kubernetes. Okay, it is a highly impressive word, and it is uh, it has the control different, it has controller and managing the entire clusters. Okay, so and what is the role of here the control plane? So you can understand like it's a role is like a manager who supervise all the employee in our office. Our manager is the main role is they are managing and supervising the employees, right? So likewise, same role here in the control plane. Okay, so here what it is managing, it is managing the cluster state, it is managing the controlling worker nodes, and it will scheduling the workloads. Okay, and also it is monitoring the health and processing the user request. Okay, so that is the role of the control plane. So in the interview, so while you are explaining the about the control plane, so you just explain likewise, it's a the brain of the Kubernetes, and it is working like a manager. Okay, and the main role is it is managing the cluster state, it is managing the controlling the worker node and scheduling the workload, monitoring the system health, processing user request. Okay, so basically the master node, it will ensure the cluster runs according to the desired configuration. Okay, this is all about the master node. Then we have worker nodes. So worker nodes are the machine where the uh, worker node or machine where the actual application runs. Okay, where the actual application it is running. So containers and the pods are executed here. Inside the worker node, we have pods, and inside pods, we have containers. So we can say in worker node, our application is running and container and pods are executed here. So the responsibility is of the worker node. It is running the application container and following some kind of instruction from the master node, and it will execute the workload, and also it will reporting the status back to the master node. Okay, so we are working in the office and we are working in the team. So we have like manager. Okay, so manager has assigned some task, and we are completing the task, and we are giving the some update to our manager. Okay, so here also the worker node, he's also like the worker nodes also like reporting to the status to the master node. Okay, so master node manages the worker nodes and the actual work. Okay, right. So if you talk about the component of the master node, okay, so we have API server. Okay, and this is one of the component of the master node. What is the role of API server? So you need to explain in the interview key the role of the API server is the main in this is the we can say like this is the main entry point of the Kubernetes cluster. So any request in the cluster, it is whether from the users or kubectl or any external system, first goes to the API servers. Okay, so if anyone want to create or any kind of things want to modify or changes, okay, this request it goes to the our API server. So API server, task of the API server, it will receive the cluster request, and it will validating the request and processing the commands and forwarding the like instruction to the other component, you can say. So you can understand it is like a reception desk, or we can say like main gate. Okay, so this is the role of API server. The another component we have etcd. So this is like a etcd, it's like a we can say like it's kind of database which stores all the data of the Kubernetes cluster, and it whatever the configuration like cluster state information or configuration details or resource kind of data, metadata, all these are stored in the etcd. So if etcd crashes, so you can say like this is the brain of the we can say Kubernetes. Okay, so if anything happen in the etcd, or else you can say like etcd crashes, so Kubernetes will lose all the information about the cluster state or whatever the configuration it has. Okay, everything they will lost, and that is why the etcd is considered the most critical component of the Kubernetes architecture. Okay, that is the role of uh, etcd. So in the interview you can say like it is the kind of database which stores all the cluster state information or configuration details or any kind of metadata about the resources. Okay, this is the very important component of the master plane or control plane. If it is crashes or fails, the Kubernetes loses a memory of the cluster configuration and the state. So therefore, it is one of the most critical component in the Kubernetes. So you also add this point: if the etcd fails or crashes, what will happen in the interview? So the interviewer get impressed. Okay. So the third point is we have the controller manager. So the controller manager continuously monitor the cluster basically, as the name itself, controller manager. So it is the role is something they are managing. Okay, its job is to ensure that the desired state and the actual state are the same. So suppose like if three pods should be running, but only two we have three pods. Okay, and the running but only two are running out of three pods, two are running. So the controller manager automatically create the third pods. Okay, That is the power of this component. Okay, if something goes wrong with the some particular pods, okay, so they will immediately automatically they will create the new pods, okay, and they are maintaining the set of pods. So it is continuously monitoring the system like we can say like watchman, okay. So that is the role of the controller manager, and it has some own component. Okay, it has some own component like node controller, we have rod controller, we have service controller, we have volume controller. Okay, so node controller. So here node controller, what is the role of node controller? So node controller means it will track the how many nodes are in the cluster, which nodes are responding, which nodes are not responding, which nodes are done, when new nodes are added. Okay, this all kind of information or things, it is managed by the node controller. Then we have rod controller. So rod controller, so one nodes want to communicate with the other nodes, okay, in the rod controller. If the one nodes want to the communicate with the other node, okay, so that what are the route of for this communication, that all taken care by the controller. It will manage the communication between the nodes, and it will determine the route path for the node to node communication. Okay, that is the role of route controller. Okay, then we have service controller. Service controller, we have like manages the load balancer and the related services. Okay, and we have volume controller. We have created the mount point to allocate the volume for the pods. So why we are allocating the volume for the pods? So we will talk about the separate questions in this series. Okay. So, but here just I am giving you the small idea here. Why we are using the volume? Because sometimes what will happen if we are not using the volume. So if sometimes pods got die or something wrong happen with the pods. So what other information it is stored in the pods, so it will lost everything. Okay, so that's why we are using the volume. So if something goes wrong with the pods, so we can get the all the details because we are using the volume. Okay, it will store all the information in the volume. Okay, so that is why this all kind of things, it is managed by the volume controllers. Okay. The next is the next component of the control plane. It is a scheduler. Scheduler is it's a scheduler decide on which worker node is new pod should be run. Okay, on which worker node our pod should be run. Who will decide this? Okay, who will decide on which node our pod will be run? So it will decide the scheduler. Okay, and while selecting the node, it will check. What it will check? It will check the CPU availability, it will check the memory availability or resource uses. Okay, so it select the best node and assign the pod to it. Okay, so it works like a manager distributing tasks among the employees. Okay, that is the role of scheduler. Okay, now we have all the component of the control plane we have discussed. Now we have another part, we have worker nodes. Okay, if you see in the diagram, so here this is the one part, that is we can call as a master node or control plane. So we have discussed this all component of the control plane. Now we have worker nodes. Okay, here also there are some own components. Now we are going to discuss about this worker node component. Okay, so here there are three main component in the worker nodes. The first one is like kubelet. So in the kubelet it's like a agent that runs on each worker node. Kubelet, it's a it's an agent and it will run on every worker node. And what is the responsibility of the kubelet? Okay, so it ensure the traffic reaches to the correct pod. Sorry, uh, I mean, the kubelet, it's like communicate with the master node, and it will ensure the pod is running properly. So kubelet, it's like agent. The role of the agent, it is communicating with the other party. Basically, in the real life also, okay, it is me. He's meeting with the client. He is meeting with the different persons, and for the business purpose or whatever he has. Okay, here also kubelet. This is the component. It is working like agent, and it communicate with the master node and ensure pod is running properly. The task is what it will taking care. It will taking care the running container, to monitoring the pod health, reporting the node status, sending the information to the API servers. Okay, this is the role of kubelet. And then we have kubeproxy. So kubeproxy, kubeproxy, it is managing a networking kind of responsibility. It will ensure the traffic reaches the correct pod and network communicate with the smoothly. Okay, so you can understand it's like a traffic controller. Okay, that is the role of kubeproxy. So without kubeproxy, how they will communicate with each component? Okay, so every like master node also it has some networking management inside. Okay, because of here the communication also inside, so it everywhere the kube proxy or it is networking inside. Okay, so the kube proxy, basically the role of it is managing the networking. Okay, then we have container runtime. So here in this section, so it is managing the life cycle of the containers. It is responsible for downloading the container image, restarting the image, stopping the container, managing the container storage. Okay, it involves handling the various tasks such as creating the containers, allocating the resource, ensuring the container health, okay, and terminating the containers. Okay, so responsible for the pulling the container images and restarting the container. This is the basically the role of the container runtime. So now this is over, and if the interviewer will ask about the architecture of the Kubernetes, so you need to explain this all. Okay, so this is one of the very important questions in the interview. Uh, so what is cluster here? So here, what is cluster? In simple term, a cluster means a group of computer working together like one system. Okay, this is called as a clusters. So it is you can say like it is a group of computers. Okay, nothing else. And what is pod? What is pod and what is node? So pod means in a pod is, we can say, the smallest deployment unit where the application it is running. Okay. So in the interview, if someone is asked, what is the pod? So pod in the Kubernetes pod is a smallest deployment unit where the application runs. A pod can be a single container or it has a multiple container. Okay, a pod, it may have like multiple container, 4 5 container, it may have one container. Okay, so pod it's lightweight, and it's a smallest unit, the smallest deployment unit where the application is running. Okay, actual in pod application it is running inside the container, but container it is inside the pod only now. That is why we are calling the application it is running inside pod, but actually the application it is running inside container. Okay, so what is then what is the node? This is pod and this is cluster. And then what is the node? So node is like simply you can say it's a machine or server, you can say, where the pod it's actually run. So in the node, inside node, we have pod. Inside pod, we have the container, okay, where the our application is running. So node it's like a machine, or we can call it a like server. So a node can have a physical server or virtual machine or cloud instances like EC2 or Azure virtual machine etc. Okay. Now the question is, what is the difference between then pod and node and pod? Okay, so you can see like that. Key the difference between pod and node it's like a machine where the application is running, and pod is it's a unit where the application actually execute. Okay, the smallest unit of the you can say the smallest unit. Okay, and deployment unit where the application is actually running. Okay, so that is the difference in differences between the node and pod. Okay, and then what is the replica set in the Kubernetes? Replica set, this is separate questions. Okay, what is a replica set in the Kubernetes? This is the part of the our interview questions. What is a replica set? In replica set, so here the replica set is a container. I mean, it's like a controller, we can say. It's a controller. It will make that makes sure the fixed number of identical ports are always running. Okay. Replica set, it's like a controller, and that makes sure a fixed number of identical pods are always running. If any pods stops, or you can say crashes or get deleted, so what replica set has do, it will automatically it will create the new pods. Okay, suppose there is a replica set, there is some set of we can say 5 pods in one packet. Okay, in one packet. So we are maintaining a 5 pods in a replica set, as we are telling. Okay, so in 5 pods, if suppose one pod accidentally got deleted or crashes, so one pod has we have lost. Now we have only 4 pods where the application or the traffic it is going through. Okay, so suppose like we have uh, our traffic will be increased. So our we have only 4 pods. It will manage all the traffic, because earlier we have 5 pods. Now it has only 4 pods. So it may be once the traffic will be increases. Okay, so it may be it is working slow or something, getting crashes or very heavily loaded happen. Okay, so in that case, once we are using the say replica set, if something is wrong with the particular pods, okay, so what it does, it is automatically it will create a new pods, and it will maintain the set of all 5 pods. If in your replica set you are maintaining 4 pods or 3 pods, so whatever the set of pods you are maintaining, okay, if something goes wrong with single pods, okay, so replica set automatically it will create a new pod. Okay, so that we can call as a replica set. So in interview sometimes they will ask what is the replica set, because this is the very like important concept we are using in the Kubernetes. So we must know about this. This is the very basic kind of things. Okay, sometimes the interviewer will ask what is the replica set. Okay, so here the same thing. Imagine you on a call center, like, and you need 5 employees always working. Okay, if one employee leaves, you immediately hire a replacement. Okay, if too many employees are working, you reduce them. Okay, replica set does the same thing. It maintains the required number of pods. Okay. हमारी in our office, suppose we are the 5 member in the team, and we are working together, and we have different roles. Okay, and if someone has leave the office, or someone has got a new opportunity, so he left the job. Okay, so finally our team, our manager, what it does, he will hire the replacement of that employee, right? So that is the thing here also. If you have lost, something goes wrong with the particular pods, so it will create a new pods. Okay, that is called the replica set. Okay. Now we have new questions. What are the services in Kubernetes? Okay, what is the services in Kubernetes? So here in Kubernetes, there are multiple services. Okay, so if you talk about the type of services, we have the first services, we have cluster IP, which is default. Another one is node port, and third one is load balancer. Okay, and fourth one is the external name services. Okay, so these are four types of services basically. If you ask, if the interviewer may ask, what are the services in the Kubernetes? Okay, he may ask in this way, what are the type of services in the Kubernetes? Okay, so you just tell like, uh, we have different services. One is like cluster IP, another is like node port, and we have load balancer. Okay, so here the cluster IP, it is a default type of services of the Kubernetes we can see. Okay, and a cluster IP services, it has like that exposes your application only inside the application. It will communicate our pod to pod communication happening inside the cluster. Okay, it will expose the application only inside the cluster. It allow the different part of the your application pod or services to communicate it, to communicate with the each other internally, but it cannot be accessed from the outside the cluster. Okay, if you are sitting from the internet, and you want to access uh, here, so you are not able to access, because it is running inside our cluster, and cluster mostly it is a private cluster. Okay, and you are not able to access from the outside. Okay, so this is the one service. It's called as cluster IP. Another one is we have the node port. Node port is services in Kubernetes, node port like services, and we can use these services to expose your application to the outside, and you can access the services from the outside Kubernetes cluster. Okay, using the IP address or any node or a specific port number. Okay, so if one of the like uh, suppose like you are different services you have, like suppose you have 5 services or 10 number of services. Okay, you want to, if you want to expose your to outside, so you can expose your services using the node port. Okay, but yeah, it will communicate from the it is not like that key internal, it will communicate with the internally only. Okay, it will communicate with the external as well. So other like when you create a node port services, okay, Kubernetes like it will assign a port number to the we can call as a node port. Okay, so the ranges of the IP address we have around 3000 to 3200 So maybe I have mentioned somewhere. See here. This is the ranges of the IP address. Okay. Uh, okay. So node port. And other one is how the traffic will be flow from the users. Okay. Suppose you are sitting outside in the network. So you want to here the port here the our application it is running. If you want to access the application which is running inside pod, okay, you send a traffic, it will come to the node port, okay, and from node port it will send the request to the Kubernetes services, okay. From there it will reach to the pod, okay. So here from here it will get the reply, okay. So node port, it's like a gateway port on every node. Okay. So once someone is trying to access our application from the outside, so first it will reach to our node port. Then only it will come. It will go to the inside our network where the application it is running our pod. Okay. So the third one is like load balancer. So load balancer, this is also kind of services of the Kubernetes, and these services is also being used in order to expose your services to the outside. Suppose you have 10 number or 20 number of services and you want to expose your all the services to the outside. Okay, in that case you can use the load balancer in order to expose your services to the outside. But you know, if you are using the load balancer, you are able to expose your all the services, multiple services. But the problem is this is not the right practice using the load balancer, because if you suppose you want to expose 5 services to the outside, okay, so for each services the separate load balancer it required. So suppose like in this case we want to expose 5 number of services to the outside. So here 5 separate load balancer we require for each services. Okay, and if you want to expose 10 services to the outside, so you require 10 number of load balancer. Okay, and all those 10 load balancer, managing of all those 10 load balancer, it is very difficult. Okay, and you never expect when it goes down or something like wrong with sometimes wrong with the any kind of load balancer. So it is also cost effective, like because of if we are using the multiple load balancer, suppose in this case we are exposing the 10 number of services to the outsides, we require 10 load balancers. So we have 10 times bill increase. Okay, so because 10 services we are using the load balancer, the billing will be 10 times increase. Okay, so our bill will be very increase. Okay, so that's why this is not the right practice in order to expose your services, multiple services to the outside. But now the question is, then what we have the option? So then we have the option is Ingress. Okay, we will discuss this question separately, but here just I want to give you some basic idea. So if you have to use Ingress, so if you want to expose the multiple services to the outside, so you can use the Ingress, and with a single Ingress controllers, okay, you can expose the multiple services like 5 services or 10 services. Okay, and you can achieve this using a Ingress controller, and you can expose the multiple services, and it will also reduce your cost. Okay, and no need to entry every time, no need to manage all those 10 load balancer. Okay, you just and also every times no need to enter the IP address to the header, or every time manual API I need to add, okay, for each load balancer. Okay. So here it is very easy to manage or expose your multiple services to the outside. Okay, so these are the main services. Here the how the traffic it is for following. So from the internet users, the request has come to the load balancer, okay, where we have public IP, and from there the request goes to the Kubernetes services, then finally reach to the pods. So this is the traffic, how the traffic it is following. If the interviewer will ask how the traffic will be flow, can you explain? So you have to explain like this architecture, okay. So this is and the fourth one, it is not important, okay, so leave that one. Now the question, the new question is, what are the multiple deployment strategies support in the Kubernetes? This is the new questions. What are the multiple deployment strategy support in the Kubernetes? Okay. So this is one of the also important questions. What are the deployment strategy you are using in the Kubernetes? In the interview questions, in the interview, they will ask what are the deployment strategy you are using in Kubernetes? Okay, so you have to explain like there are multiple deployment strategy we are using. The one is recreate, another one is rolling update, and we have blue green deployment strategy. We have canary deployment, A/B testing. Okay, the important deployment strategy we have rolling update, blue green, canary. So here you need to at least you need to prepare these three: rolling update, green, blue green, canary. Leave that this one and recreate. Okay. Uh, Deployment strategy in the interview, if they will ask, okay, you just count this number, okay, but you have to explain this theory. This is the main. In the market, mostly they are using this. Okay. So rolling update, uh, it is kind of default and mostly most widely used in deployment method in the Kubernetes. Instead of like replacing all the pods at once, the Kubernetes gradually terminates all the pods, and it will start new pods in control batches. Okay. So here it will what it does, instead of replacing all the pods at once, Kubernetes gradually terminates all the pods and start the new pod. Means you understand what exactly here. Suppose you have one environment where all the traffic it is going through that, okay, but now you want to create one more environment, okay. So what you do, you are planning to create separate environment, okay, and you want to finally switch to the new environment, okay. Earlier you have everything you have set up, but some services you want to introduce or something you want to modify, okay, some features you want to add. In that case, you are planning to create new versions, new environment. In that case, there are multiple deployment strategy you need to follow. Here I'm explaining rolling update, okay. So here in this case, how it will be changing one environment to the another environment, okay. So here instead of replacing, because definitely we have already managing the clusters and we have nodes, pods, everything it is running already. Now we are creating new environment. So instead of all the pods at once, Kubernetes gradually terminates old pods and starts the new pods. Okay. In this way, it will uh, switching to the from old network to the new environment. Okay. So some old pods or some new pods are running, ensuring the application remains available. You can configure how many pods can be created or removed at a time. Okay, if something goes wrong and Kubernetes allow easy rollback at the previous version, so best use for like most production application that requires the zero downtime or we can say like smooth upgrades. Okay, so this is the default methods. So another method we have blue green, that is one of the very important technique we are using, blue green. So in the blue green, so we have uh, two identical environment running simultaneously. So the current live version is like blue, we can call as a blue. This is current version, which is where the traffic it is already running. Okay, now we are moving to the new environment or new version, we can say, we can call as a green environment. Okay, so old environment we can call as a blue, new environment we can call as a green. Okay, so here once I validated the traffic, instantly switched from the blue to the green environment. Okay, at the same time, also we are, once we have moved all the things, the traffic from blue environment to the green environment, so at the same time also we are managing the blue environment, because if something goes wrong with the green environment, we can roll back. Okay, we are doing some kind of testing. Once we have everything, it is I mean 100% ensure like everything is working fine, and there is no any kind of issues, and our application it is running smoothly, then finally you have to uh, delete this old environment. Okay, and if something goes wrong with the green environment, you can instantly roll back without the, I mean, downtime, near zero downtime. Okay, so here in the blue environment, you just explained we have old environment that we can call as a blue, where the all current traffic it is running. Okay, then we have new environment we have created, we can call as a green environment. Okay, then we can route all the traffic to the new environment, and at the same time we are monitoring this all. Okay, if something goes wrong, we can roll back immediately, and if it is working fine, then we have to delete this old environment. Okay, now the fourth one is canary deployment. In this deployment strategy, canary deployment strategy, we have uh, here also the same scenario. We have old environment, here is a new environment. But the way of shifting the traffic from old environment to the new different environment, it is different totally from the blue green or rolling update, which is the default one. Okay, here slow like a small amount of traffic we are routing from the old environment to the new environment. Suppose like 10% traffic we are routing from new environment to the old environment. And then at the same time we are also monitoring. Okay, if it is working fine, there is no any kind of issues, it will, the reflecting. Okay, then we have to increase the 10 to 20%, 30%, 40% traffic, and then we are testing, we are checking, we are waiting. Okay, and so if it is working fine, then again I have to increase the amount of some traffic like 60%, 70%. Okay, then we have to monitor. Then finally, if working fine, then 100% traffic we have to move. Now the question is how these things we are managing, how we are doing that, how we are managing this all. So this all doing using the YAML pipeline. So here you have to mention like the amount of traffic here. Yeah, the YAML, you need to create the deployment YAML here, and which one it is? Rolling update YAML pipeline here, and the here canary deployment. So here you can see the we can change here we have replicas 3. Okay, and this is maybe this is old environment. Okay, now we have to change the this environment to the new environment. Not the replica we have where it is match. Hmm. So here, how the amount of traffic we have to increase or decrease. So how we can achieve this? So using the replicas, as we already explained, what is replicas? It is maintaining the set of pods, right? So here I have to mention the in the replica section in the YAML file three. If we want to increase the amount of traffic, we have to change these three. It means like around 30% traffic it is moving from here. And if you want to increase the traffic, you have to change the replicas for the new environment here. Uh, here you can say here. Here, replicas one. Here you need to change like replicas like 5 or 6. So it will be moving the traffic from old environment to the new environment, and the percentage wise like it will increase. Now it is around 10% traffic it is moving from this new environment. Okay. So slowly we have to increase 10%, 20%. We have to change that to 20%. We have to change the three like 30%, then 50, then 60, then 80, and then we have to 100%. In this way we can so in an interview, the interviewer may ask how to change the amount of traffic, how you are managing the amount of traffic. This question maybe they will counter these questions. Okay, so you just explained we need to change the replicas sections. Okay, like 2, 3, 5, 6, 7, 8, slowly, and at the same time you are keep monitoring these all. Okay, whether it is working fine. Finally, if something goes wrong, we can roll out. Okay, so this is all about the canary deployment, and this is the you just write this copy paste this YAML. You just create a folder, you can deploy. Okay, no problem. This is very simple. Now, what is label and what is selector in Kubernetes? This is very basic question in Kubernetes. Okay. And other thing also we have deployment, and what is we have uh, क्या बोलते हैं deployment, and we have replica set. Okay, replica set हो गया. Okay, हम देखेंगे. And what is the label over here? So in label, so we have like replica set, then we have deployment, and then we have labels and selectors. Okay, so replicas I think you have understand already. Okay, deployment, it is used to deploy or manage an application in the Kubernetes. We can call it deployment. So replica means it's running multiple copies of the same pod. Replica means running the multiple copies of the same pod. If one pod failed, another pods like ensuring running the application, and also it will the Kubernetes will create the new pods. Okay. Now the question is what is labels and selectors. Okay. So we have already discussed about the replicas. Okay. So now what is the label and selectors? So label and selectors are basically it is used in Kubernetes to identify and correct resources. Okay, so we have different resources, right? So how to identify which resources is like for this purpose, which is this resources for this purpose, and we have similar kind of resources. We have And okay, so how to identify the correct resources? So labels are like a tagging system. Labels are like a tagging system through the which we can group the pods and services, or we can say deployments. Okay, and the selectors are use those tags to find the correct resources. So it is like we are using in the kitchens. We have different boxes we have in the kitchens, where we are keeping like salt, sugars, tea powders, or something masala. Okay, so we are just similar kind of if you are using the similar kind of box. Okay, so to easily in order to easily identify which boxes for what purpose we have stored. Okay, you just putting some labels over there. So this is like sugar, this is tea powders, this is this is this. Okay, so once you are cooking. Okay, during that time, so it is easily to find what exactly you are looking for. Okay, you can easily pick that one. Okay, the right box, because you have a similar box, multiple similar box. Okay, but you can pick the right box. Okay, why? How it is possible? Because of you are using the labels over there. Okay, so label, it's like key value tag. It is attached into Kubernetes object like pods, nodes, deployments. Okay, and it will help to identify the group, and it will organize the resources. Okay, so yeah, that is why it is like a stickers of an item that describes what are the the boxes. One, it's like electronics, or here box two like types of cloth, or box three like electronics. So what are the box you have uh, kept inside? What are the things? So you just put those label outside, so that easily you can find the right box. Okay, that we can call is the labels. And selected, it's like uh, selected, basically it is uses those tags. Okay, to find the correct resources. Okay, and another thing is what is the namespace in Kubernetes? This is also the basic things. Namespace is like a logical separation mechanism inside the Kubernetes cluster. Okay, in simple terms, like name is like a folder. Namespace, it's like a folder where we organize related resources such as the pods. Then we have services. We have deployments, config maps, secrets, kind of things. Okay, so we can logically we can divide we can doing some partition. Okay, so that is being called as a namespaces. Okay, so why we are using the namespaces? The main purpose of the namespaces is to make, organize, and manage the management. We can say easily. The first benefit in organization, by keeping the different projects in separate namespaces, resources do not get mixed. Okay, if you are using the namespaces. Okay, suppose imagine a large office in a building, so which represents a Kubernetes cluster. Okay, inside that building, so we have different companies are working. Like company A, it is on the second floor. Company B, it is in third floor. Company C is on the fourth floor. Okay, so all companies share the same building, but each company has its own separate space, right? So in that way, it's a namespace provide a separate space inside the Kubernetes, right? So for that reason, we are using the namespace. Okay, because this is very basic things, so we cannot ignore this. Okay, so now the important question is, what is config map, and what is secret, and its use in Kubernetes? What is it? The config map, and what is the secret in its and what is the uses in Kubernetes? Okay, so basically the config map and the secret, why we are using the Kubernetes. So when an application runs inside the pod, it needs some kind of configuration value, right? For example, we have whatever the database URL, API, and application environment, or password you have, or any other things like say tokens. Okay, if these value are hard coded inside the application, it's become less flexible and less secure. Okay, so the Kubernetes, it will store the configuration and the sensitive data separately using the we have a config map and the secrets. Okay, so every employee it has some confidential kind of data. It has like user ID, password, API keys, or some other important documents. Okay, and they don't want to like where it needs some it need to be stored some places where the nobody can read, or nobody can hack those sensitive information. Okay, so for that reason, how to keep safe this? So where to store and what you need to use in Kubernetes? In that case, we are using the config map and the secrets. Okay, so right, so here the config map, it's like Kubernetes object. We can say that store the non-sensitive configuration data. Config map, we have two parts. One is map and other is secret. So in config map, it will store the normal configuration data. You can just explain likewise first. In the secret sections, you are responsible to uh, save like some kind of sensitive information, like sensitive confidential data, like user ID, password, APIs, keys. Okay, so that sensible information you need to store. Okay, where you have to store in the secret. Okay, this makes application flexible or secure, or we can say easy to manage, right? Okay, so we have like the small YAML file over there. You can write the YAML file, how you are using the how you are managing the config map or secret, so using the YAML file. So everything, yani, everything in order to manage all those things in the Kubernetes using YAML pipeline, YAML code. Okay, YAML file you can say. So here this is the YAML for the config map. Here API version v1 we are using config map. If you are using the secret, so other things you need to mention in the kind sections. Okay, the metadata we have mentioned, and whatever the uh, app environment productions. Okay, so yeah, the use of config map, the change config without the rebuilding app, separate the code and the configuration, easy environment management, and centralized configuration. Okay, and now what is the secrets? The secret is, it's in Kubernetes. It's also, it is kind of object, and we have to use to store the sensitive data, sensitive piece of data. Uh, we have to store securely. Okay, it usually stored what, the password, or API keys, database credential, token, certificates, kind of things. Okay. Uh, you know that we are using the debit card, credit card, whatever the we have, ATM pin number, bank password, Wi-Fi password. Okay, everything. Where you need to store in the secret section. Okay, so how this is happening here inside? So API version v1 kind of secret here, kind in the kind section you need to mention the secret. If you are using the writing the YAML file pipeline for sorry, YAML file for the config map, here in the kind section you need to mention the config map in place of the secret. Here we are writing the YAML file for the secrets. So here I am using the secret here, metadata type, and user ID. This is the my user ID or or whatever you have, you just write your password and you can store. So nobody can see that this information. Okay. So application reads this securely. Why we use secrets? So it will protect the sensitive data and it will avoid the exposing password in code. Okay, and secure access control, encrypt the confidential information. Okay, these are the benefit using the secrets. Okay, so the key difference between the config map and the secret sheets. So config map, inside here we store the non-sensitive data, like configuration kind of data we are storing now. This is non-sensitive. Okay, but in secret we have sensitive data we have stored, and the config map, because this is not the confidential kind of information and it will be it is in the plain text format. Okay, but here in the secret, because we are using the storing the password or some confidential kind of thing, here it will be encoded. It is not like the plain text you are able to, you can see that information. Okay, it is not like a readable format. Okay, and here app setting configure, app setting, here passwords, configuration details we have we stored in config map, here security related. Okay, that is the main difference between the config map and the secrets. Now, because the question is, where do we create the config map and the secrets? Inside the Kubernetes cluster, you told. You just in the interview, you just explained. So if they will ask, where you to, Rahul, where you have to store the config map and secret in the um, in the Kubernetes, okay, or anything he asks, okay. So you just tell, okay, we need to store this all Kubernetes map, config map and secret in Kubernetes cluster. So more specifically from the your local machine, laptop, or using kubectl commands connected to the cluster like EKS, AKS, GKE. Okay. So yeah, this is all about and how to create. So these are the steps we have. Uh, this is the YAML pipeline for the production environment. Here the same thing. So we are writing for the YAML for the config map. For which environment? So we are using for the production environment. If you are using for the your testing, so you need to mention that environment like prod or staging, okay, or whatever the color we have, okay. So yeah, and the file name is config.yaml. Extension is .yaml. It must, here anything you can put, but here extension is, it must be .yaml. Okay, and once you have to deploy, you want to deploy, how to deploy? You just, this is the single command in order to deploy whatever the file you have. So kubectl apply -save, and here the file name kubectl apply -save. If the interviewer will ask how to deploy this, so you just tell, okay, I have to apply the kubectl command like kubectl apply -save config map. This is the file name. Okay, it will be get applied. Okay, this is the YAML for secrets. Now the question is, what is volume in Kubernetes? Persistent volume. What is persistent volume and what is the persistent volume claim, PVC? What is persistent volume, PV? What is the persistent claim, persistent volume claim, PVC? So in interview, they will ask, oh, what is the difference between PV and PVC? So PV means persistent volume. PVC means persistent volume claim. Okay. So here, as I explained in this uh, today class, what is the volume? What is the purpose of using volume? So volume basically we are using a volume is stored to attach the pod to container, can store and share the data. Okay, by default container store it's in temporary. A volume gives extra storage while the pod is running. But important point, data stay even if the container is start. Data is lost if the pod is deleted. Okay, if you are not using the volumes, if pod is deleted, so you have lost everything, whatever the information you have stored in that particular pod. Okay, that's why we are using the volume. So imagine working on the laptop and saving the files in a temporary folders. Okay, if the laptop shut down permanently, the data is gone, right? That's like normal. Suppose you have opened the laptop and you have opened the file, okay, and you have worked something, and once you have, set on your system, if you have not saved, so you will lost everything. Okay, so the same way here in our network Kubernetes cluster also things are happening the same. So in order to avoid this kind of things, we are using the persistent volume. Okay, so if something goes wrong with the pod, so even after, so we have not lost our information. Okay, so for that reason we are using a persistent volume. Now persistent volume, it's over. Persistent, what is the persistent volume? A persistent volume, it's permanent storage in the cluster. Okay, volume we understand what we are using, but what is the persistent volume? So persistent volume, it's like permanent storage in the cluster, you can say, right? Permanent storage. Remember this word, permanent storage in the cluster. So it is created and managed separately from the pods. If exists independently, even if pod is deleted, data stays safe. Sometimes, as I already explained, something is wrong with the pod. Sometimes accidentally the pod is got deleted. So in that case, you have not never lost the information which is stored in that particular pod. Okay, so we can get all the details from there because we are using the persistent volume. Okay, so where we have exactly we have to store, we have to use the like Azure EBC, AWS EBC, Azure Disk, GCP Disk. So okay, this is the storage uh, area where we have to store. Okay, locally. Now we have persistent volume. What is the persistent volume claim? So a persistent volume claim, PVC, it is a request for storage made by the application. See the differences. The persistent volume, it is permanent storage. Persistent volume, it is permanent storage. But PVC, it is a request for storage made by the application. That is the difference between the PV and the PVC. That is the permanent storage. PV is permanent storage. In PVC case, it is request for the storage made by the application, where the application is running inside pod. So instead of choosing the storage directly, the pod says I need 10 GB storage with the fast performance. So Kubernetes find a matching PV and connect it. How they work exactly? So a storage admins create the persistent volume. A storage admin, if you are the admin, so you need to create the persistent volume. Application create the persistent volume create. Application create the persistent volume create. So Kubernetes binds PVC to PV. Pod uses the PVC to access storage. So the pod never talks to PV directly, only through the PVC. Here is the comparison. Okay, same thing what I have explained. So volume, what is it? It is temporary storage for pod. Who create? So pod spec, if you are an admin, so you are responsible to create. Lifetime, lives and the pod. Persistent volume, real storage resources. Who will create? Admin system. And persistent volume correct. It is storage request. And who will create? Application or developer. Okay. So this is all about. And now the question is how you will create, why? How you will create volume? So here again using the YAML. The YAML code for volume, persistent volume, and this is the single command to deploy this volume. So Kubernetes apply -f, this is the common. Here, this is the file name. Here, pb.yaml, I have put it the name. If you want to put anything, but .yaml, it is C. It should be same. Must be same. Okay, that means storage. Here, per PBC. This is the example of the PBC. Okay, persistent volume claim. Okay, so if you have to create PB and PBC already you have created, how to check that? So you have to use that command kubectl get PBC, kubectl get PB. Okay, so you can see all the information about the persistent volume or persistent volume claim. That's in Kubernetes, persistent volume provides the actual storage in the cluster. Persistent volume claims is a request for storage made by the application. Okay, that is the thing. So this question is also it is basic questions. What is the resource limit and the request in the Kubernetes? Resource limit and the request in the Kubernetes. So resource request, a request is the amount of CPU and the memory Kubernetes reserved for the container when the scheduling on the node. Okay, a request is the amount of CPU and the memory Kubernetes reserved for the containers when the scheduling in one node. Okay, so what is the minimum resources my container need to run properly? So Kubernetes should uses a request to decide which node has enough capacity to run the pod. Okay, so if the container requires 500 M CPU or MI memory, so Kubernetes ensure that the node at least that much free resources. Okay, so the resource limit means they're asking about the resource quota. Okay, how much you need to be uh, giving the some storage to the particular container. Okay, that is the resource limit or resource quota. Now the one of the important question is what is tent and toleration and its use case in Kubernetes? What is the tent and toleration in the Kubernetes? Any, one second. So tent and tolerations in Kubernetes, uh, this is one of the very important questions for the interview perspective. Okay, interviewer may ask what is tent and toleration in Kubernetes? So basically in Kubernetes cluster, there are multiple nodes we have, right, in the Kubernetes cluster. Like suppose we have node 1, node 2, and node 3. Okay. So on these nodes, so we have like multiple pods or schedule where the actual application it is running. We already know we have nodes in the clusters, and inside nodes we have different pods. Inside pods our application are running, right? So suppose we have uh, three nodes, node 1, node 2, node 3. So in that uh, uh, we have multiple pods scheduling actual application, but sometimes in certain nodes it has like special restrictions we can say applied in some nodes. Sometimes some special restriction applied which is called as a tent. Sometimes in this case we have three nodes in the clusters: node 1, node 2, and node 3, where our pod it is running and where the application it is running inside pod. Okay, so in some pod we have some kind of we can say mm, the restriction applied in particular node. Okay, So when the tent is applied in a node, the Kubernetes scheduler does not allow a normal pod to be scheduled on that particular node. Okay. So suppose node 1 and node 3 have a tents and node 2 has no tents. Tent means some kind of restriction. You just understand like that. Tent has some kind of restrictions. Okay. Or who has, we have three nodes in the cluster, node 1 and node 2 and node 3. Suppose we have node 1, node 3. In node 1, in node 3, we have tents. Okay. There may be 10 means there is some restriction over in this node. Node 1, node 3, there is some restriction means some, it is, we have tents. But node 2, there is no tents. Now when the pod it is created and the scheduler checks whether that pod has permission to tolerate that particular tent or not. If the pod does not have toleration defined, then it will not be scheduled on node 1 and node 3 because it has some tent. And it will automatically be scheduled on the node 2 because there is no restriction, there is no tent over there. Okay. So in the simple, tent is applied on the nodes and the keep pods away. Once you have applied the node tent in particular node, so pod never schedules on that particular node. Okay. So why we are using this kind of restriction? Suppose in our Kubernetes clusters, so we have master node, we have worker nodes. So pod always goes to schedule in the worker node. It is never being right practice to schedule our pod in our master node. Why it is not getting scheduled in master node? Because it has some tent. Okay, that's why pod is never placed in the master node. Okay, and it is going to be placed where there is no restriction, means there is no any tent available there. If because the pod it has some they don't have particular toleration for this particular tent. Okay, they don't have some toleration for this particular tent. That's why pod is not going to schedule that particular pod where the tent is applied. Okay, so pod is going to schedule on those nodes where the tent is not applied. You understand? Okay, so that is the tent and toleration. So basically it is in production environment, this mechanism is very important because it helps to control which workload run on which node. In Kubernetes cluster master nodes, we have control plane nodes, right? So usually it has a tent so that normal pods do not run there because the master node job is to manage the cluster where the API server or scheduler or controller manager here it has basically the main job is to so major job is to manage the cluster. Okay, so it is managing the overall cluster, it is not managing the worker node, okay, where the application is running. Okay, so that's why the pod is not able to schedule the master node. Okay, so that is the things about the tent and toleration in the interview. Most of the times interviewer will ask, but this is also one of the most important questions. So yeah, suppose you have like some high performance nodes with the CPU, RAM, high RAM, you have GPU. These nodes are reserved for the special workload like databases workload, machine learning, GPU workloads, high proxy, I mean priority enterprise application. Okay, so even this taints are applied on those nodes so that normal pods do not run there over there. Okay. The second use case is isolating the unstable nodes. If the node becomes unstable or its hardware issues, a taint is applied so that new pods are not scheduling there. Okay, because of the some there are some hardware maintenance it is going on or hardware issue it has. So I don't want to schedule that node in that particular node because it has some issues. Okay, so why we have to schedule that particular node, I mean pod over there. So how to stop this? So we have to apply that in over that particular node so that no pod will be going to schedule on this particular node. So this keeps the cluster stable and avoid downtime. Okay. So third use case of separating the production or testing the workload, right? So that is all about the taint and tolerations. Okay. Here the example we have taint node 1, node 2, node 3. Okay. If you can see here, so if you can see here, so we have pod. And here we have three nodes, node 1, node 2, node 3. And in node 1, we have taint. That means there are some restriction over there. And node 2, there is no taint. Okay, there is no restriction. And here node 3, we have taint. Here also it is some kind of restriction. Okay. So our pod is once going to schedule in these all three nodes. So here it will get repaired. It will not schedule because of this particular taint, because pod has some toleration. They don't have some toleration for this particular taint. Okay, so pod is not going to schedule here node 1, and neither this pod will schedule here node 3. So finally it will schedule here in the node 2 because here is there is no taint applied. Okay, hope you understand. So here is some kind of effects. There are some property over there in that ends. So that is one of the very important property. So in the interview, might they will ask what are the property of the tents you are using. So we have no schedule. This is one of the property. Then other is prefer no scheduling. Prefer no schedule. And third one is no execute. So no schedule means pod will not be scheduled unless they tolerate existing pod remains. Okay, this is no schedule. Prefer not schedule. Kubernetes try to avoid scheduling, but it may allow if needed. Here prefer. In this case, no schedule. Once you apply this effect now, so pod is never schedule that particular node. Okay. Once you have to apply this property, prefer no schedule. So first it will check the is there any node where I have to this pod need to will schedule. If they have not find the right node to schedule that node. Okay, so then finally it will be it will allow okay ठीक come and schedule in this node. Okay, so this is the meaning of the prefer no schedule. Then third one is no execute. So pods without toleration are removed and evicted immediately. So strongest restriction you can say. Okay, so these are the property or the effects you can say for the tent. Okay, here is the YAML for this. Here I'm using the no schedule here effect colon no schedule. That means pod is never scheduled in this particular node. Okay, fine. Now The another question is like similar questions. What is node affinity and the NT affinity in the Kubernetes? This is also one of the very important questions. What is the node affinity and the NT affinity in the Kubernetes? So node affinity and the NT affinity, this is also playing the same role in order to schedule our pod in the node, but it has some advanced scheduling mechanism in the Kubernetes. This is also doing the same task like taint and toleration, but this is some kind of advanced uh, scheduling mechanism compared to taint and tolerations. Okay, so node affinity and node anti-affinity are advanced scheduling mechanism in the Kubernetes, we can say in the interview. So normally the scheduler automatically decide where to run pod, but sometimes we need to define rules so workloads run on the specific nodes. That is where the node affinity is used. suppose suppose uh, you are booking a hotel rooms, okay, you are booking a some hotel rooms and you give some condition like I want to see view room, okay, I want to see view room and I want to only fifth floor I have to stay, I want to book my room fifth floor. This is like similar to selecting the nodes in the Kubernetes, okay. So because of the fifth floor you can once you book the room in the fifth floor you can able to see the view from the outside, or if your hotel nearby sea, so you can view the beautiful scene from the sea from your window, okay. So if you are stay in the you are booked the room in the ground floor, so you are not able to see that view, okay. So in the same way here the meaning the selecting the nodes in the Kubernetes, this is very similar. So if you say I don't want to roam near the elevator, so that becomes an avoidance rule. So Kubernetes rule the scheduling the works in the same way. So what is the node affinity then? So node affinity, it will tell the Kubernetes that a pod should run on specific nodes based on the labels. So node have labels like environment is equal to production, or we can say a disk is equal to SSD, or anything you want to. This is the label you are mentioning in the disk. Anything you want to put. Okay, the reason is zone is here in this zone. Okay, so scheduler checks these labels and place pod accordingly. So here it will check, it will schedule the pods using the label and selectors. Okay. In the previous questions, the pods are getting scheduled using the taint and toleration. Where the taint is already applied in the node, the pods are not getting scheduled. But here, how the pods are getting scheduled using the label and selectors. Okay, this is the property it is being used in the node affinity. Okay, so scheduler checks these labels. If the label is matching, then pod is scheduled accordingly. So what are the types of the node affinity? Here, what are the types? So we have required nodes affinity, hard rule, pod. You can see here types of the node affinity. So we have required the types. This is the like you can say like this is the property or effect we have. Okay, so required means it's very hard. Pod must run on the matching nodes. If the labels are matching, then only pods will schedule that particular node. If the label is not matching, then it will never schedule. Okay, that is very hard. Okay, preferred means it's like a soft rule. Okay, ठीक है, अगरचे कोई नहीं मिला तो तुम मेरे पास आ जाना भाई, ठीक है, कहीं जगह नहीं मिला तो ठीक है आ जाओ मेरे पास, तो इस तरह की बात है. सो pods are try to check matching nodes. If it is not available, then runs else anywhere. Okay, so example like prepare SSD nodes, but okay, if not available. Okay, if it is not getting fine SSD levels, then it will schedule anywhere. Okay, that is all about the node affinity. Then we have another thing like node anti-affinity. What is node anti-affinity? So anti-affinity, node anti-affinity, it is used when we want to avoid certain nodes. And node anti-affinity, it is used when we want to avoid certain nodes. Okay, so nodes, I mean, if the node has label like environment is equal to test, okay, this is the label, then production pods should not run there. This ensure like productions app run only on the stable nodes. If you talk about the differences between the node selector and the node affinity, what is the difference between node selector and node affinity? So node selector, it's like simple method with the exact label matching, you can say. And node affinity is, it's like advanced. It will support the logical condition like and, or, in, not. So this and, or, in, not, this is we can call as a logical conditions. Okay, and support both hard and soft rules. Okay, hard rules means once the level is matching, then only the pod will do that pod node. And soft rule means if the level it is not matching, then after that it will schedule anywhere. Okay, likewise. So that is soft rule. That is the difference. Okay, already discussed. So node affinity here in the bottom line interview answers, node affinity is used to schedule pods on nodes based on the level conditions. It can be hard or soft rules. Node anti-affinity, it is used to prevent pod from the running on certain nodes. Both the provide advanced control over the port placement. Okay. This is all about the difference between node affinity and a node selector. Okay. Next question is how to schedule pod on a master node. This is counter questions by the interviewer. Once you explain that this is not the right practice to schedule a pod in on master node, okay, and the pod it is going to schedule in always worker nodes. Okay, so once the interviewer will ask, okay, I know that, I understand pods, it is not right practice to schedule a pod in the master node, but yeah, I want to schedule the pod in the master node. How you will schedule that? If this kind of questions, if the interviewer will ask that, how to explain, right? So how to explain? You explain like by default, Kubernetes does not allow pods to run on the master, like in the control plane means. Okay, so generally it's not recommended to schedule a pod on the master node in the Kubernetes. Why? Because the master node is typically reserved for the managing the cluster and its component. To run critical component like API server, scheduler, controller manager, so is to protect using the tents. It is protect using the tents. We have applied the tents. Because of the tent, the pod is not going to schedule in the master node. But to schedule a pod on the master node, you have two standard methods. You have two standard methods. Still, you want to schedule your pod in the master nodes. So how to schedule? This is the question. Okay, I know this is not the best practice. We never, because the taint is applied in the master node. So pod is never placed in the, they never schedule in the master node. But is there any way, is there any chance to schedule the pod in the master node as well? So yes, it can be possible. There are some methods in order to schedule our pod in the master node as well. So first understand the reason. So master node means like control plane node has a taint. So here the some property it is applied no schedule, like this is very hard. So never so any kind of pods here. This taint actively blocks the pods. Okay. So before anything else, pod must be allowed to tolerate the taints. Otherwise, scheduler will reject it. This is the key rule. Okay. So can node affinity alone schedule pod on the master? No. Not by itself. Node affinity only say I want this pod to run on this node. Node affinity only say I want this pod to run on this node. But if that node has taint, so scheduler still blocks it. So affinity alone is not enough. So what toleration does? Toleration says this pod is allowed to run on a taint node. It removes the restriction. Without toleration, pod never scheduled. So real production approach, correct architecture would be when you want a pod on master node, you typically use both toleration and node affinity. This is the right answer. So how you will explain? Key for still you want to schedule your pod in the master node. So only if you want tolerations, it will not work. And only if you want to use node affinity, also it will not work. So we need to use the combination of the toleration and the node affinity. Okay. So what it does, it forces the pod to specific node. It will force to schedule the pod in this node. Means like in this case, we want to schedule our pod in the master node. Okay. So your answer will be toleration and the node affinity both. Why both are used in the real system? Features, purpose, toleration allow pod to on master and node affinity ensure pod goes specifically. So you just read this answer and memorize this, and now you can uh, then after you can explain the same thing in the interview. To schedule a pod on the master node, how you will explain in the interview? This is the very important line. Very important. You just remember this line. So once it's okay. Once to schedule a pod on the master node, toleration is mandatory because master has a no schedule 10. Node affinity alone cannot override 10 in production. We typically use both toleration and the node affinity. Toleration allow the scheduling and the node affinity ensure the pod runs specifically on the master node. Okay, that is all about. So the next question is, what is rollback access control, authentication, authorization in Kubernetes? Rollback access control, what is that? Rollback access control, authentication, authorization in Kubernetes. So in Kubernetes security, authentication, authorization, and rollback access control work together to control who can access the cluster and what they are allowed to do. Authentication and authorization or rollback access control, RBAC we can call in short. So what is the role of this? What is the purpose of using this? So the purpose of this, so who can access the cluster, because we are managing the cluster and it is a private cluster, and where the application, our application, it is available. Okay. And it should not like access everyone, and it should not like do some any kind of things and modify something. wrong. Okay, so how to maintain this all? So we can use the authentication, we can use the authorization, we can use the rollback access control. Okay, so all together to control who can access this cluster and what they are allowed to do. So think of it like ensuring that office building security checks who you are once you are going to the company the first time. Okay, so once you are going inside the office, so first the security checks who you are. That means this is the authentication. Then they check what area you can enter, कहाँ जाना है, where you want to go. Okay, so that is authorizations. Okay, and the third one is access rules are defined by job roles. Okay, so here the what level of access you have. Okay, because someone has contributor access, someone has we can say like admin access, someone has read write access. Okay, so we can control this all using the rollback access control. Okay, so authentication means who are you. Okay, authentication verify the identity. Okay, authentication verify the identity of the user or system making the request to Kubernetes. When someone runs the command like kubectl get pods, the Kubernetes API server first checks, is this person or system valid? Okay. Okay, then how Kubernetes authenticate users? So Kubernetes supports multiple identity methods. So it will check the client certificate, tokens, or identity and access management. Okay. So this if the identity is verified, the request moves to the authorization. Sorry, first authentication. If this request is verified, then the next it will goes to the authorization. Here, uh, if not access, it is denied. So authorization, what it does, basically what are you are and what kind of allowed you have. So once the identity is confirmed, the Kubernetes checks the permissions. So whether this person is able to access the pod or whether this person is delete the services or that person is only there view the secrets. Okay, if the permission exists, a request allowed, if not, so forbidden. So Kubernetes authorizations and the uh, I mean we have authorization and क्या है something authentication. Okay, then third one is rollback access control. Here, rollback access control is the most widely used in authorization mechanism in the Kubernetes. Okay, it defines who can do what on the which resources. Okay, so because we have different memory in our project, so it has different rules. Okay, based on that, we our project manager or admin, so he has to give the some level of access according to his role. Okay, so who someone has having the contributor access, someone has admin access, someone has like read write access. Okay, so here manager suppose like manager approve the budget, developer deploy apps, viewer read the report. Each role has permissions. Rollbacks access control work exactly the same way. This is all about the authentication, authorization, and the rollback access control. So the main component of the rollback, we have role and the cluster role, and we have the role binding, cluster role binding. Okay, so there are four main role of the rollback access control. Main component. One is role, another is cluster role, third one is the role binding. The fourth one is cluster role binding. So it is very easy to remember. First is role. It is individual. A role is define a set of permission within a specific namespace. It describes which actions can be performed on which resources, such as reading pods or updating config. Okay, it will define the permission inside the namespace. Okay, so example read pods, create deployments. Okay. Then another one is here. See, this is the role. Here cluster role. The role will be same, but the place will be changed. Here it will be particular namespace. The role is, I mean, playing here, but here the person is playing in the cluster level. Okay, cluster level. So that is the name of the I mean for the remembering role. This is the individual namespace. This is for, and this is for cluster level. So the name will be changed from role to cluster role. Okay. Then third one is role binding, and this is the individual role like a role, but for the cluster level the name will be changed cluster role binding. Hope you understand. Okay, this is the how you can easily you can remember role and role binding, role and cluster role. Huh? This is the individual and this is the cluster level. Then third one is role binding, then cluster role binding. Okay, in this way. So role in the Kubernetes, a role is defined as set of permission within the specific namespace. And the cluster role, a cluster role is similar but apply to the entire cluster instead of the single namespace. This is the main line. You just remember this. Just you understand, na? So never you will not forget. Okay. So a cluster role is similar but apply to the entire cluster instead of the single namespace. And the use nodes, it is used for nodes, persistent volume, all namespaces. Okay. And third one is role binding. It will connect a role to a user's group or service record within a namespaces. Okay. And then we have cluster binding. The cluster binding perform the same function at the cluster level. That's it. Now this is the counter questions. This is very important questions. Okay. And this is the last question for today's class. Okay. So now how to restrict the access to my pod so that Azure can access it, but Rohit cannot. How do we implement this in Kubernetes? Suppose once again I want to read this. How to restrict access? How to restrict access to my pod so that Azure can access it, but Rohit cannot access. Suppose you have in your team there are multiple persons. Okay, you have your colleague. Okay, so one is junior, you are senior. So you want to give some level of access. So one is like pod and where the application is running. Okay, so you can able to access, but other one, your junior, will not able to access this pod, particular pod, because this is very critical pod. Okay, so you want to restrict them. Okay, this is the example, but in our team there are maybe some other team, developer team. Okay, they no need to access this pod, but yeah, because he's working with you. So how to restrict them? Okay, so what is the process? How to restrict? So you are able to access, but other cannot be able to access this. This is the question. Okay, so this is about the user permission control. So who? The person identity can access the Kubernetes resources. This is handled using the rollback access control. First answer. What you have to answer in the interview? So this thing I can handle using the role based access control. So problem statement, you want to control access to a pod such that Azure allowed to access the pods, but Rohit not allowed to access the pod. This means Kubernetes must check who the users is and what permission they have. Then only Kubernetes come to know, right? Who is the user and the user what kind of permission it has. Okay, so based on the permission Kubernetes will allow. Okay, so this means the Kubernetes check who the user and what permission they have. Okay, the first it will check, there are three layers control. Okay, three layers. First is authentication, identify the users. Kubernetes must first verify the identity. Common enterprise methods like corporate identity, identity provider, Azure AD, Okta, LDAP, these are the methods it is using. Client certificate, OIDC, most common in cloud. IAM integration, EKS, GK, EKS result. Kubernetes knows. This request is from Azure or this request is from Rohit. Okay, so first Kubernetes identify this person. So he has identified this request. This request comes from the other side. This request comes from the Rohit side, because both are trying to access that particular pod. Even I want to access this pod, and Rohit is also want to access this pod. So two requests has generated, and both the requests have gone to the Kubernetes. Now what Kubernetes will play. So after identity is verified, Kubernetes check the permission. So once they have Kubernetes verified the identity, okay. So he understand like both the person is a valid request, okay. Both he is from our organization, okay. He is not from the any kind of third party or outside world, okay. He is the part of the our this project, or he is the part of this the organization, okay. So now the Kubernetes is verified. Now the second level of checks, they will check the community will check the permission. So raw or rollback access control decide what actions user can perform. What action? So first it will check Azure what he has tried to access, and also it will check what Rohit tried to access. Okay, so it will check. So based on the resource or request, it is come from the Rohit or Azure. Okay, it will check the level of the access, what permission it has already. If there is some kind of modification, Rohit want to do some kind of modification, and Kubernetes checks Rohit want to do some kind of modification in the Kubernetes cluster, but it has no the right permission. Okay, if they don't have the right permission, so they are not the right person to modify this Kubernetes cluster. Okay, so what Kubernetes what it will do, it will deny, right, it will deny the Rohit, and it will allow the access to the Azure, because Azure he has the right I mean the permission, okay. Because of the right permission, the Kubernetes giving approval to Azure can do the any kind of modification, okay. Either he want to modify, or other he can delete or any kind of things, okay. So these are the three way need to be used in order to this question is right, how to restrict access to my pod so that Azure can access it but Rohit cannot. How do we implement this in Kubernetes? Okay, so this is the answer. This is the like the YAML pipeline. Now the question is, it will come in your mind. Okay, I understand the things, but how will implement in real time? So here, this is the code. Okay, YAML code. If you can see, so here kind is role, metadata, name, pod access role. Pod access, it means he want to access that particular port. Okay, pod. So namespace, it's a production environment. So rules, it is defined API group, resource pods, verbs, get, list, watch. So this is the like access level. It is defined in our YAML manifest. Okay, get list means that means it has the right permission to access the pod. Okay, so this is the meaning. Now see the another code. Okay, and now this is the code. This is okay. This is the code. This is role. Create a role. First step I need to get, because we are two person. One is Azure, one is Rohit. So I'm giving the permission. How we are restrict them. So these are the steps you need to explain in the interview. So in the first, I am creating the role. So this is the YAML of the role. Here you have to, in this section, resource is equal to pod, you have to select. Okay. Here this is the role. And verb section, you have to get list was. That means the person has all the access. Okay. Define the permission. See here. Now we are creating the role binding. Okay, first we have to create the role, then we have to role binding. Okay, this is the here in the YAML you have mentioned kind user name is equal to Azure. Okay, and pod access role, this is the role you have to define. Okay, finally step 3, this is Azure for Azure. Now we are going to create for the Rohit, gets no role binding. Okay, no permission assigned, Kubernetes denies. Okay, so here the thing is, if you want to get the access to the pod, so uh, you need to like give this permission. Okay, you need to write the code, YAML code, and you need to provide the access here in this way. Okay, if you don't want to, if the Kubernetes, I mean, you don't want to give the right permission to the Rohit, so no need to explicit like need to create the explicit YAML file line. You just leave it. Automatically Kubernetes block that person. If you want to allow, you need to write this code and you have to mention this, the username or user ID, everything. So this person is able to access. If you are not, don't want to, else anyone has to, are able to access this port, no need to create any kind of rule. Automatically the Kubernetes will block. Okay, that is the thing. That's why I'm not written any code for the Rohit, because automatically Kubernetes will block. Okay, so that is the thing. I think time is over. It's 11:30. So we can take the snap of these questions. Taken. Take this page as well. Taken. Taken. Okay. Fine.